Hello everyone, today I thought I would give you guys an overview of SAP ABAP Objects if you already know a little Java programming. So learning the object-oriented concept, if you've not been introduced to any other sort of programming in the past, is a little bit overwhelming, but you'll find that most modern languages nowadays do support some form of object orientation. So for this course, this video that you're listening to right now, if you've programmed in Java, if you've programmed in C++, C#, JavaScript, Python, any of those languages, all those languages support object-oriented programming. And some, of course, do support procedural programming. I'm looking at you, Python, and C++. But so basically, I'm just going to go ahead and try and introduce you to the subject with the assumption that you have some knowledge of an object-oriented programming language. So when I first started this video, I said, I need to find an object-oriented programming language, and I couldn't think of anything more object-oriented than Java, in my opinion anyway, because you literally cannot write a program without first having a class. So assuming that we know Java, we have our class here in just whatever package. So we're going to do public class main. And now there are certain different, of course, things we can do within a class to make a blueprint for a class. We can say like private int my num. So let's go ahead and pull up in the ABAP editor. I'm just going to say z_oop Java. We're going to create a brand new program. Just give it a name. Go ahead and just make it an executable program, and that's good. Save it as a local object since we're not going to be transporting it to a productive system or any sort of quality assurance system, and just wait for it to finish. So now, in our ABAP over here, we're going to want to go ahead and replicate. We're just going to go ahead and create a Java class, and I'm going to replicate it in ABAP and explain it along the way. So in ABAP, you have two parts of creating a class. Class, let's call it LCL for local class because it's not created in SE24, which is the class builder, which is essentially like a data dictionary for classes. And that's going to be a global class. And most of those would actually be prefixed ZCL. But in this case, this class, even though it's in global scope of this report, it's a local class to the program. So we're just going to call it LCL main because over here in Java we've called our class main. And then we need to give it a definition. And the class statement has to be followed by the in-class statement. And we need to give it a definition. Now just like in Java, you can have public, protected, or private members of a class. In ABAP, we do this by public section, protected section, and private section. And each of our data elements are going to be defined within one of these sections. So we have private int my num, so we can go to private section. And just like we declare any other variable in ABAP, we're going to do data my_num. I'm just going to keep with the naming conventions of both languages on either side, so don't worry about that. Let's say we have in Java, if we have a public method, public, and it returns an integer, get my num, and it's going to return the private class variable. My num, and then we have a method which returns nothing. So public void set my num takes in as a parameter int a number, and it sets this dot my num equals a num. So in ABAP, what we need to do is we need to go ahead, and this is the definition part in ABAP, guys. This is essentially just saying this is the class, these are the names of the methods with parameters and return type. So in the definition section, all we're going to do is define these different parts of the class. And I guess I should have mentioned, guys, public, protected, and private works exactly like it does in Java. If it's private, then only the class can actually access it. If it's protected, then subclasses can access it. And if it's public, anybody can access it. So we actually don't have to define protected if we're not going to use it, or private if we're not going to use it. But if we're going to define all three, they have to be defined in this order: public, protected, private. So now let's replicate our Java class. So public section, I'm going to say methods, because this is an instance method of main. I can't just say main dot get my num. I have to have an object of main. So we're going to say methods get my num, returning value, and then we'll just say my num, and then it's going to be type I. So what this returning value says is we're going to return this, passing this parameter back to the calling function by value. So, you know, pass by reference, pass by value. That's a thing that you should know if you've studied another programming language, especially an object-oriented programming language. So that's what's going to happen here with get my num. We're going to pass it by value back to the calling program. And then we have another method, set my num, in Java. We're going to go ahead and define that here. And this is going to import, which means it's going to take in a value, my underscore num. Well, actually, let's go ahead and give these different names so we don't confuse it with the actual private data here called my num. Let's just call it num. Importing num, and we'll give it a type. And in ABAP Objects, you need to have a type. You actually can't return anything here unless it's typed. So now you'll see we've got the method defined. We're saying this is a method called get my num. It returns a value of integer. And then a method set my num, which imports an integer value. So in Java, the implementation section is what's between the curly brackets here in these methods. This is the actual implementation. Now in ABAP, you can define a class, which is what we have here under class LCL main definition. So the class can be defined, but later on, we can actually implement it. So to implement a class in ABAP, we're going to go down here and do class, give it the same name as our local class main, and say implementation. And this also has to end with an end class. So to implement a class in ABAP is extremely easy. We just say method, the name of the method we're implementing, so get underscore my underscore num, and it has to follow with an end method. So this is the implementation. So at this point, we know we're returning the value num. So all we have to do to return a value in object-oriented ABAP is to say num equals my underscore num, which is from the private data of this class, from the private section. So it's essentially saying return this dot my num. Same as in Java, it's just a little bit different syntax. Now let's implement the other method that we've said. Actually, if we go ahead and let's just say check this program, we can go ahead and check it, and it'll actually give us a warning that we haven't implemented set my num. So every method needs to be implemented in a standard regular class. So method set my num, and the beauty of it is do method and method. Since we've said importing num type I here, we don't actually need to specify that signature down here. Num is available to us in the context of set my num. So we can say set my num, we can say my underscore num equals num, num being the value that the calling object is going to pass to this, and my num being the private data from the private section of the class. So now we have created a class in Java and its equivalent class in ABAP. So now what we could do is we could go ahead in our Java program, create another class. It's kind of strange really, because in ABAP I can come down here and I can say initialization, I can pick an event block, and then I can start to work. In Java I can't do that. I have to, it's such an object-oriented language that I have to create an entire new class. So we'll just go in Java, we'll say create a new class, and I'll call it report. And in the report class, I'm going to create a main method. This is one thing ABAP doesn't necessarily have. So you can think of this initialization block as being the main method of our object, of our program. So in here, this public set void main signature method is going to be the same as initialization for the purposes of this tutorial. If you guys are familiar with Java and you're familiar with ABAP to some extent, you already know what I'm saying is kind of an abstraction of how it really is. But we're going to, in Java, say main equals new main. And all this is doing is the same thing as in ABAP saying data, local reference main, type ref2, which means this object main refers to the type or the class LCL main, which is the same thing here in Java. We're saying of type main, create a variable just called main, and it's a new main class, which is essentially the same thing here in ABAP. So then we're going to say create object LR main. So this is the same thing as doing this whole statement in Java. It is creating an instance of the object LR main of type LCL main. So in ABAP we can do it this way. We can say create object. We can use factory methods for those of you familiar with the factory design pattern in Java. But so this is essentially saying allocate an instance of LR main. So now from this point in Java, we'll go back over to our Java IDE here. We'll say main dot set my num. We'll give it a value, say 12. So to do it in ABAP, we say LR underscore main, which is our reference variable. And then we do the dash greater than symbol. And that's going to provide us with, I'm just doing control plus here to get help for whatever the available methods and data are. So I can see I have a method here that's available called setMyNum. And in Java, I've got main.setMyNum. So I'll just say this. And we'll call it just like in Java. And in ABAP, if something only takes in an importing value and it's just one, we can go ahead and pass that without specifying the name of it. If it's multiple importing values, say we had one over here that was called num, another one that was called letter, another one was called delimiter, something else, we'd have to actually say importing num equals, and then letter equals something like that. But since we only are having one importing parameter here, we'll just say 12, which is what we set over here in Java. So then we have another method that we defined, getMyNum. So let's go ahead and create a local variable, data. Let's just call it lvNum, local variable num, type I. And then this is what's known as a functional method. We get a we call a method and it returns one value. So then in ABAP, we can go over here and we can say lv underscore num equals local reference main, getMyNum, and the value from getMyNum, this method called, will return num, which is going to be my num, which is whatever that we've specified in our private section here. So then, we could say, let's just do a breakpoint so I can illustrate the point here. And then what we're going to want to do is do the same thing in Java. So we say int, we call it lvNum over here in ABAP. That doesn't make too much sense to call it that in Java. Let's just say a num, don't initialize it, and then we'll say a num equals main.getMyNum. And then in Java, we'll just say system.out.println, which is just go ahead and print out or write to the screen my num. So then we'll run our Java report.main, our main method of our report class, which is going to call our main class, which mirrors this LCL main here. And all it's going to do is call this code and print out the result a num. So we'll go ahead and right click it and run report.main. And we see 12 is printed to the screen because we set our main classes, and via set my num, it set this private value my num to 12. We declare a variable. We assign the variable to main.getMyNum, and we print a num. So we end up with 12. So if we do the same thing in ABAP, we go back to main so we can see it here. Local class main, we have a public section. In our public section, we have two public methods. These are instance methods. So we have two instance methods here, and then the implementation for those two instance methods here. We have in the private section some data, which is just an instance field or variable here, and that is set and gotten by our two instance methods. So in our initialization, which you can think of as just the main method of another class, we create an object of type LCL main. We call set my num to set this private section data value here to 12. Then we define a local variable, and then we retrieve the value of LR main, get my num into that local variable, and we create a breakpoint here. So we'll go ahead and check it. Everything checks out. We'll go ahead and activate our z_oop_java. Go ahead and continue. And then we can go ahead and run this. It'll open up a session for the debugger. And from our debugging session, we can go ahead and click on any variable, or double click on any variable name here that we want to take a better look at. So we can say, I want to look at, where is it? LV num, double click on it, and our value is 12, which if you look at our Java class, we did the exact same thing in Java syntax, and our value is 12. So that's a basic overview, guys, of how object-oriented programming works in ABAP Objects. Again, if you're familiar with Java, C#, any of those programming languages where it's all about the objects and everything has to have its own class, and you can't just come out here in Java and delete this class and start writing statements. It's not going to compile because this is a completely object-oriented language. ABAP Objects is the way of the future for ABAP and SAP. We can expect as ABAP developers to see more and more of this paradigm in the future. So even if you just have a fair understanding, or you're coming from another programming language, if you're a Java developer or whatever, make sure that you understand at least the basics behind object-oriented programming, behind polymorphism, data hiding, abstraction, inheritance, all those things that are just so central to object-oriented programming, because you're going to see less and less of just this procedural chunk of code that you're seeing in ABAP, and more of actual classes with implementations and definitions. And in modern day ABAP, for an actual transactional model ABAP program, we wouldn't even have this initialization part here. Everything would be handled in a class. And when we go to create a transaction, what we're going to do is for that transaction, we're going to say, all right, so this is an object-oriented transaction. What we need is to create an instance of this class. You'll define the class. And for that class, you're going to say what method to call. And that's going to be what kicks off your actual report or your ABAP program. So anyway, this tends to be the way that most languages are moving nowadays, is the object-oriented programming paradigm. The design patterns that are associated with it, so your factory design pattern, your observer, your actor design patterns, all of that's going to be very important to learn. So if you, then again, this video is mostly meant for guys that already know Java, or like I said, some other programming language that really focuses on object orientation. So there'll be further videos to better explain this concept, both for Java developers and object-oriented programming developers, and for you guys who may not necessarily have any sort of exposure at all to object-oriented programming. We'll do a separate series for that, and we'll explain it from the ground up. So as always, if you guys have any sort of questions, feel free to leave it in the comments section. My email is always on the video description on YouTube. I check it frequently, so please feel free you know, to leave me any sort of comments or questions you have. And as you guys can see, let's look at the clock here. It's 7:56 on a Friday. I do this because I love it, but it also takes time. So, you know, if you guys appreciate it, I really appreciate you if you would leave, you know, at least a like. If you really want to make me happy, go ahead and subscribe. But thank you guys for watching. I hope I was able to help at least a little bit, and we'll see you in the next videos. Thank you.